Percent dissociation is the percentage of hydronium ions, H plus ions, that exist in solution for a specific acid. Percent dissociation is dependent upon concentration, and so that is something important to remember. So let's do this together. Suppose you have 72 molecules of a strong acid in an aqueous solution. It's very important that it's in solution. If 100% of these molecules dissociate, how many H plus ions will be present in the solution? This should be an obvious answer to you. 100% of 72 is equal to 72. So there'll be 72 H plus ions in solution if 100% of the strong acid molecules dissociate. The percent dissociation described in the problem above is redundant because a strong acid always dissociates completely. That means 100% dissociation. Let's look at how we do this with molarity, because as you know, acids are generally spoken about in molarity from their concentration. Suppose you have a solution labeled 0.02 molar. What is the molarity of H plus ions in the solution? As you know, HCl is a strong acid that will dissociate 100%. 100% of 0.02 molar is 0.02 molar H plus. In real life, it would be H3O plus. The H plus ions will attach to the water and you get H3O plus, hydronium ions. The next question says we need to find the pH of the solution. Remember that the pH is based upon the concentration of H plus ions in solution. So if it's a strong acid, then the concentration of H plus ions is equal to the concentration of the acid. That's what we just did in C. You can use a calculator, but if you remember how to do log math, you don't need a calculator for this. Remember that the equation for pH is the negative log of the H plus concentration like that. And we can change the form of 0.02 to make this work a little bit easier. So we're taking the negative log of 2 times 10 to the negative 2 molar. And seeing it in this form should make this a doable problem for you, because remember that you add the logs together when they are multiplied. So the negative log of 2 is negative 0.3, and the negative log of 10 to the minus 2 is 2. So the answer to this is 1.7. That is the pH. It's a strong acid, it's very acidic, so the pH is going to be low. Now we're going to look at percent dissociation and pH for weak acid solutions. You should recall that what makes a weak acid is that it does not fully dissociate in a solution. Suppose you have 120 molecules of a weak acid in an aqueous solution. If 5% of these weak acid molecules are dissociated at equilibrium, how many H plus ions will be present in the solution at equilibrium? We're going to talk later about what it means to be in equilibrium, but for right now, for all intents and purposes, at equilibrium means that the H plus concentration is steady. In order to solve this problem, we'll have to take 5% of 120. You can do this with a calculator, so why don't you try that now? 5% of 120 is 6 H plus ions in solution. That also means that there are 114 weak acid molecules, which I'm going to represent as HX, H being the hydrogen that can dissociate and X being the rest of the acid molecule. This is a general way to write an acid formula. And so we're looking at how many are dissociated and how many are not dissociated. So now we're going to look at this question, but in terms of molarity, because that is how you will see acids. You will not see them as molecules because remember, 1 mole has 6.022 times 10 to the 23 molecules in it. So you'll never be able to get down to an amount where you only have 120. So let's look at a molarity. Suppose you have 0.25 molar solution of a weak acid in an aqueous solution. If 1% of the weak acid molecules are dissociated at equilibrium, what will the molarity of the H plus ions be at equilibrium? In order to do this, we'll need to take 1% of 0.25. You can use your calculator for this, so go ahead and calculate that. And the answer is 2.5 times 10 to the negative 3 molar H plus. Don't forget this molar unit. That is the label. That is the concentration of H plus in solution. Now we're going to find the pH of the solution. And remember, again, the pH is equal to the negative log of the H plus concentration. So we're looking for the negative log of 2.5 times 10 to the minus 3. And if you do this in your calculator, which you should try now, the answer is 2.6. Suppose you have a 0.34 molar solution of aqueous lactic acid. Lactic acid is a weak acid. It has a COOH group, a carboxylic acid group. If the H plus molarity at equilibrium is 0.020 molar, what percent of lactic acid molecules are dissociated at equilibrium? And this is where we get to the idea that percent dissociation is dependent upon the molarity of the solution. So we can solve this by dividing the molarity of the H plus by the molarity of the lactic acid. 0.020 molar H plus, 0.34. All right, try and figure out the percent dissociation. And if you solve this, you'll get 5.9% dissociation. Last question, using a calculator to determine the pH. You actually don't need a calculator for this question. You can do this just with your log math. So we're looking for the pH of the solution, and remember the pH is only dependent upon the H plus concentration in solution. So we're going to take the negative log of 0.020, and this is easier to work with if we write it with exponents. So this is equal to the negative log of 2 plus the negative log of 10 to the minus 2, and we get 1.7. All right, you should be able to do the rest of the practice problems on your own.